Hello everyone, welcome back to our inverse trig function conversation. We've been talking about finding derivatives of them. So this is actually a side note lecture of sorts on how we can rewrite the cosine of the arcsine of x. How can we rewrite cosine of 2 arcsine of 2x? So how are we able to rewrite this in a straightforward polynomial setting? So let's go ahead and look at this problem and just do a couple of things that you've actually learned from previous math classes. So the theta here. So if you look at cosine of the arcsine of x, the theta is going to be the arcsine of x, or the inverse sine of x, right? Because this is cosine of theta. So we don't care what theta is, but we're looking at this, so this is going to be the angle of this function. So one of our previous lessons, we talked about this, that I can rewrite this. So arcsine of x equals theta is the same thing as sine of theta equals x. In this case, we're going to make it over 1. Because we've had a conversation in the previous video about how we can create a triangle on this. So we have sine of theta is equal to the opposite side over the hypotenuse, because SOHCAHTOA tells us that we can do this. And then in the previous video, when we were deriving, when I showed you guys how to take the derivative of arcsine, we went ahead and found this side by the square root of 1 minus x squared. Now, once you've done that, once you have done this, this now turns into theta. You used the fact that theta is equal to arc sine of x, or that sine of theta equals x minus 1. You use that to come up with this triangle. So now when you want to find the cosine of theta, you just simply have to look at this triangle. So this answer is going to be the adjacent side, which is going to be 1 minus x squared all over 1. So this here is equal to the square root of 1 minus x squared, which is pretty awesome for us to use. Question number 2. We're going to do the same thing with what we just did on example number 1. We're going to acknowledge that theta is going to be, now notice for this one it says cosine of 2 and then the arc trig function. So in these questions, usually theta is going to be the arc trig function. So I'm going to rewrite this as cosine of 2 theta, because I can use a double angle for this. So theta in this case is going to be the arcsine of 2x, the arcsine of 2x. So again, we can rewrite this as sine of theta is equal to 2 over x, or sorry, 2x. So that means that if we do our triangle here, we're going to get that this is going to be 2x, and this is going to be 1, because again, SOHCAHTOA. This is going to be, the sine is equal to the opposite side over the hypotenuse. And then we're going to use Pythagorean theorem to find the side right here, just like we did in the previous examples. So 1 squared is equal to 2x squared. Be careful about this, right? Plus question mark squared. So just be careful that we're squaring the 2 with the x. So we're going to get 1 equals 4x squared plus question mark squared. I can move the 4x squared over, and then I'm going to take the square root of that, and so I'm going to get that this is equal to 1 minus 4x squared. Okay, 1 minus 4x squared. So again, we took the fact that the arc sine of 2x equals theta is equal to sine of theta equals 2x. We used this, we assumed the hypotenuse is over 1 because it wasn't given to us, so it's inferred that it's 1. 2x, 1, and then we use Pythagorean theorem to find this. Now, where our issue lies here, ladies and gentlemen, is the fact that this is asking us for cosine of 2 theta. We don't have 2 theta, we have 1 theta. So we can use an identity to make this double angle to a single theta. And so we can say that cosine of 2 theta, and there are 3 different ways to do this, but this is the one that's the most obvious and one that we're just going to use right here. So cosine of 2 theta is equal to cosine squared theta minus sine squared theta. So our answer to this is going to be, well, what is cosine of theta? Well, cosine of theta is going to be the square root of 1 minus 4x squared all over 1. And we're going to square that. So this piece right here is simply that, using again that cosine is the adjacent side over the hypotenuse, our good old friend SOHCAHTOA. And then we're going to subtract, well, we already know what sine of theta is. We already know it's just 2x, right? We can look in our triangle, or we can do it right here. So we're going to take 2x and we're going to simply square it. So our answer to this is going to be the square root of 1 minus 4x is simply going to be, what I was getting ready to write right there, I think I was getting ready to write the square root again, 1 minus 4x squared, right? If I square this, I get that, minus 2x quantity squared is going to be 4x squared. So our answer is going to be 1 minus 8x squared. So these are the same thing. So this is going to be equal to 1 minus 8x squared. All right, guys, so you guys can see that there are practice examples that we can do here. And I actually want to skip down to, I was going to change it to x over 2 over here, but I just saw that question number 10. It's exactly kind of what I want to do. So let's do one where we get x over 2. So let's start with that question, example number 10. So first thing we're going to notice here is that theta is going to be equal to the arc cosine of x over 2. So cosine of theta is going to be equal to x over 2. So if we draw our triangle, like we do here, we're going to have theta here. So remember that cosine is the adjacent side over the hypotenuse. Okay, so this is one where we actually have a number that's right there. So cosine is going to be the adjacent side over the hypotenuse. So I need to find this side right here. So again, we're going to go ahead and square the hypotenuse, and we're going to square our side, and then we're going to do our question mark side. So we're going to get 4 equals x squared plus question mark squared. And we don't need to keep doing this because most of you guys can do this in your heads, but this will be probably the last time that I need to do this with you guys. But question mark squared is equal to 4 minus x squared. So now we can say with full confidence that we can get that this is going to be 4 minus x squared, right? 4 minus x squared. Once we have done that, so I'm going to go ahead and get rid of all that. So once we've done that, this is now theta. So once you've drawn your triangle, you can replace all of this because what we just used in this theta gives us this triangle. And now, ladies and gentlemen, all I need is the tangent of theta. I need the tangent of theta. Well, the tangent is going to be the opposite side, which is the square root of 4 minus x squared, all over the adjacent side. So this answer is going to be equal to the square root of 4 minus x squared over x. And that is really all that you need to do for that. So let's look at question number 9. Let's keep the challenge going here. Actually, let's do one more that's a little bit more. Let's do question number 4 first, a double angle one, and then we'll get to the secant double angle for the secant one. So let's look at this one. So again, example number 4. So hopefully with a lot of practice, you guys are going to see in that we're going to make this equal to 2 theta, right? So this is going to be the sine of 2 theta. And so theta is going to be equal to just the arc sine of x. Okay? So just like many times before, we're going to get that this is our sine of x is equal to x. So we've actually created this triangle several times now. So I don't need to spend too much time on this. This is going to be x, this is going to be 1, and this is going to be 1 minus x squared. All right, so pretty straightforward with that. So remember, ladies and gentlemen, for this exact example, we're looking at the sine of 2 theta. Well, we only have theta. So we have to use an identity here, and we have to use the double identity for sine that says this is going to be 2 sine of theta cosine of theta. And so all I have to do now is find out what sine of theta is, cosine of theta, and multiply them both together with 2. So this final answer we're going to do here is going to be 2. So this is going to be our right answer, 2. And so sine is going to be, again, we've already know that. Sine is just going to be x, right? It's going to be x over 1. And then cosine is going to be the adjacent side over the hypotenuse, which is just going to give us 1 minus x squared. So I'm going through these pretty fast because it really just doesn't take too much thinking to do them. And like I said, the more practice you do, the better you're going to become at it. All right, so let's look at that one. You guys okay with this? All right, I think we have one more. You guys, I see there's a cosecant right there, but I'm going to do it down here with this one right here. So you guys will do a more challenging question for number 9. So let's look at the last question. All right, so for question number 9, it says secant of 2 arc cotangent or cosine. So the first thing you want to do here is again acknowledge that we have theta is equal to arc cosine of x. Now, our issue here is that we're going to be left with secant of 2 theta. Well, a fix with this, because let's say who knows what the double identity is for secant, so we can rewrite this as 1 over, one over the cosine of 2 theta. So we can solve this problem and then just put everything underneath 1. So we're going to rewrite secant as 1 over cosine of 2 theta. And that's what you would do for the problem that we just did, the one that I showed you guys at the top of the page. So now that you guys know this, we can say that, again, cosine of theta is going to be equal to just simply x. So just like plenty of times before, we go ahead and draw ourselves a triangle. And here's our theta. And so our cosine over hypotenuse is going to be right here. So it doesn't matter if the x is here or the one's here. We're still going to get that this is going to be 1 minus x squared, right? So Pythagorean theorem tells us it's going to be the square root of 1 minus x squared. So now we have that. So all we have to do to finish this problem out is now writing this as 1 over the cosine squared theta minus sine squared theta. Because again, cosine of 2 theta is equal to cosine squared theta minus sine squared theta. And again, we had to use this identity because this is only theta, or this is theta. So let's look at cosine. Well, again, we already know what cosine is. Cosine is simply x, so we're going to square it. So we're going to get x squared. We were told that in the problem. Minus the sine is going to be, and we can go ahead and write this over here, the sine of theta is going to be equal to the opposite side over the hypotenuse. So all I need to do is square this, and so I'm going to get that this is going to be parentheses, don't forget parentheses, 1 minus x squared. And so all we have to do now to finish the problem, ladies and gentlemen, is actually just to distribute the negative, and so we're going to get x squared minus 1 plus x squared, so we're going to get 2x squared minus 1. And that's how you do those type of questions. So I hope that makes sense, because we're going to see these guys again in the next couple of lessons. They're going to pop right back up. So that's it for this lesson, and I will see you guys in the next video.